Hey guys, welcome. Yeah, so example 2 here. So I assume that you've watched example 1, and therefore I'm not going to go through the same details as example 1. But example 2 is slightly harder than example 1, hence why it's example 2, because this time we get a remainder. And that's because we know x squared plus 1 is not divisible by x plus 1 from the get-go. And that's because we know that x squared plus a number a is never factorable. Right? It's not factorable over the reals, right? And so we know that x squared plus 1 is not equal to x plus 1 times some other linear, right? We know that that's not true. Therefore, we know that we're going to get a remainder. Okay, otherwise, by what we said in example 1, what we do to start the process of synthetic division is we take whatever we're dividing by, which I just circled, and set it equal to 0 and figure out what that number is. So here we set x plus 1 equal to 0. Clearly, the answer to that is x equals -1. And we take -1 and put it in this box, yeah? Okay, cool. Next, we take the polynomial we're dividing and we write its coefficients in the order that they should appear. So the coefficient of x squared to start, that's 1, right? There's a 1 there, that's not written. And then next is supposed to be the coefficient of x, but there is no x term. So its coefficient must have been 0, and we need to write it. So you write a 0. And then after that is the constant term. And so that's this one here, and so there we are. Okay, now next what we're gonna do is we're gonna take this very first number and write it below this line, yeah? Okay, now that we've written it below the line, we multiply this number here to what's in the box. So 1 times -1 gets us a -1, which we write right there, yeah? And now we add down. So 0 plus a -1 is -1. And then now we take this number and multiply to what's in the box. So -1 times -1 is +1, so we write it right here, and then we add down and we get a 2. And I said in example 1 that this number, this last number, is our remainder. So we have a remainder, and the remainder is 2. Yeah? Okay, cool. Now, since this was x squared here, sorry, I don't like the way I wrote that. Since this here is x squared, this here is 1 degree less, so it must be x. And so our answer is x minus 1 remainder 2. But this is really how you should write your answer. Start with the original problem, which is x squared plus 1 divided by x plus 1. And then go, this is equal to, and now we're writing the answer. And the answer is x minus 1 plus, and it's always plus even if your remainder is negative, plus your remainder, which is 2, divided by our divisor, which is the thing we divided by, which is x plus 1 in this case. So this is how you write your final answer, and this is correct. That equation holds. And the reason is because look, if I multiply both sides of this equation by x plus 1, look at what I get. I'd get, well, on the left side, I'd get just an x squared plus 1 equals, and then on the right side, I'd get this times x plus 1. So I get x plus 1 times x minus 1. And then plus this times x plus 1 is just a 2. I wrote another plus sign, my bad, y'all. And then plus 2, yeah? And now this here is equal to that, because this here using difference of squares is x squared minus 1. X plus 1 times x minus 1 is x squared minus 1. So x squared minus 1 plus 2 is x squared plus 1. Yeah? Okay, cool. But the point is that you have to write your answer in this form between the two parentheses. Yeah? Okay, cool. All right. Now, last thing is I'm going to show you another way that we can check that our answer was correct. And by our answer, I mean this answer here, x minus 1 plus 2 divided by x plus 1. So that answer, x minus 1 plus 2 divided by x plus 1, is correct. And I'm going to show you another way why it's correct. Yeah? Okay, and this is pretty clever, so like it's worth your time. Yeah? Okay, cool. All right, so check this out. So the task we were given, and I'll do it in a different color, I guess, like be less tedious. But yeah, like we know that the task we were given was figuring out what this is, right? X squared plus 1 divided by x plus 1, right? So here's what I'm gonna do. I'm gonna say that the numerator can be rewritten as x squared minus 1, but wait, there was no minus 1 here. So to make up for it, I go plus 1, right? And so far I've just written x squared, and that is x squared plus 1. So since this is just x squared, I need to write plus 1 to make it x squared plus 1. Now this here is just a weird rewriting of x squared plus 1, right? And I'm going to lump this 1 plus 1 here at the end to a 2. And I still have a correct statement, that is this here is the same as that there, yeah? This here still reads x squared plus 1. Okay, cool. It's just a weird rewriting of it, right? Okay, cool. And I go divide by x plus 1, right? Okay, cool. And then I go, yeah, so if I so chose, I could write this divided by that plus this divided by that, right? And that's what I'm going to do. In other words, separate it into two rational expressions, right? So I could write this over x plus 1 and then plus 2 over x plus 1, right? Okay, cool. And then by difference of squares, we know that this here, by the way, I have a video on difference of squares, but yeah, and on binomial squares, period. But yeah, this, and well, not, sorry, difference of squares and binomial squares. I have videos on those, so watch that. But yeah, this here, x squared minus 1 by difference of squares is x plus 1 times x minus 1. And then we have that divided by x plus 1, right? And then, of course, we have the plus 2 over x plus 1. I said binomial squares, period, but a difference of squares is not a binomial square. That's why I kind of stuttered, try to backtrack. But clearly, as soon as I canceled this here from the top and bottom, what I'm left with is what we claimed was our answer. Yeah? Okay, cool. All right, that's it for example 2, and 5 more examples to come. Keep watching. Take care.